everyone, hope all of you are doing well. In this video we are going to discuss the NCERT in text questions and solutions from the chapter Electricity of grade 10. The previous questions are already discussed in part 1. Now we can move to the first question. The first question is from page number 216 and question number 3. The question is, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? Here we have to write down the advantages of parallel connection. In the case of a parallel combination of resistors, the voltage is constant. That is why we will get the same potential difference across each appliance. So we are using the parallel connection in the case of household connections and all. Also, we will calculate the effective resistance of the parallel combination as 1 by R equal to 1 by R1 plus 1 by R2. So that means the effective resistance will be reduced. Okay. So how we can answer the question? We can answer like there is no division of voltage among the appliances when connected in parallel. The potential difference across each appliance is equal to the supplied voltage. The total effective resistance of the circuit can be reduced by connecting electrical appliances in parallel. So that is the answer. Now question number 4. How can three resistors of resistances 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? In this question, three resistors are given, that is 2 ohm, 3 ohm and 6 ohm. We have to connect the 3 in order to get the effective resistance of 4 ohm and 1 ohm. Okay, so these two circuit diagrams we have to draw. Suppose we are connecting the 3 ohm and 6 ohm in parallel. So how we can calculate the effective resistance? If we connect in parallel, that is 6 ohm and 3 ohm, we can calculate the effective resistance by using R1 R2 divided by R1 plus R2, that is 6 into 3 divided by 6 plus 3, that will be 2 ohm. Okay. Suppose we are connecting the other 2 ohm with this effective resistance 2 ohm, then how we can calculate the effective value? That will be R1 plus R2, that is 2 ohm plus 2 ohm, then we will get 4 ohm, right? Now we can draw the circuit. Here we can see that the cell is connected and the 3 ohm and 6 ohm are in parallel. That means the effective value will be 2 ohm. Okay. Then that 2 ohm is connected in series with the 2 ohm. So the total resistance will be 2 plus 2. That will be 4 ohm. Okay. Hope it is clear. Now we can answer like this. This equivalent resistor of resistance 2 ohm is connected to a 2 ohm resistor in series. Therefore, the equivalent resistance of the circuit equal to 2 ohm plus 2 ohm, that is 4 ohm. Hence, total resistance of the circuit is 4 ohm. In the next part of the question, we have to get the effective resistance as 1 ohm. So, how we can calculate? So that we can calculate the 2 ohm, 3 ohm and 6 ohm in parallel. Then we can draw the circuit diagram as shown in the figure. Here the 3 ends are connected together in order to get the parallel connection. Now we can check how to calculate the resistance effective value. Here the resistors are connected in parallel, that is why we can calculate the effective resistance as 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So to get R we can take the reciprocal, that is 1 by 2 plus 1 by 3 plus 1 by 6. So we will get the value as 6 by 6, that is equal to 1 ohm. Therefore the total resistance of the circuit is 1 ohm. Next is question number 5. What is the highest and the lowest total resistance that can be secured by combinations of 4 coils of resistances 4 ohm, 8 ohm, 12 ohm and 24 ohm? Here we have to calculate the highest and the lowest effective resistance by using these 4 resistors, that is 4 ohm, 8 ohm, 12 ohm and 24 ohm. Okay, that we have to find out. There are 4 coils of resistances 4 ohm, 8 ohm, 12 ohm and 24 ohm. Okay, in the first case we have to get the highest resistance. For that we can connect them in series, because the equivalent resistance in the case of series connection is R equal to R1 plus R2 plus R3 plus R4. Okay, so we can add these resistances in order to get the highest resistance. Okay, so the value will be 4 plus 8 plus 12 plus 24, that is 48 ohm. In order to get the lowest equivalent resistance, we can use the parallel connection. Okay, so by using the parallel combination, we will get the equivalent resistance as 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So we can substitute the values, then it will be, the value of R will be reciprocal of that value, that is 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. The value will be 24 by 12, that is 2 ohm. That is the lowest value of equivalent resistance. Therefore 2 ohm is the lowest total resistance. Our next question is from page number 218. First question, why does the cord of an electric heater not glow while the heating element does? The question is, the heating element glows, but why the cord of an electric heater is not glowing? The reason is the heating element of the heater is made up of alloy, which has very high resistance. So when current flows through the heating element, it becomes too hot and glows red. But the resistance of cord, which is usually of copper or aluminium, is very low, so it does not glow. Now the second question is, compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Here we have to calculate the heat generated. The charge is given as 96,000 coulomb and the time is 1 hour and the potential difference is 50 volt. Now we can write down the given quantities, that is Q equal to 96,000 coulomb and T is given as 1 hour, that we have to convert into seconds, that will be equal to 60 into 60, that is 3600 seconds, and the potential difference V is given as 50 volts. Now we have to calculate H. So from Joule's law of heating, we have H is equal to VIT. Here I is the current, but we don't have I, right? Only Q and T are given. So how we will calculate I from that? We know that I is equal to Q by T, right? So we can calculate the value of I, that is I equal to 96,000 divided by 3,600, that will be equal to 80 divided by 3 amperes. Now we can substitute all the values in the equation H, right? H equal to VIT. Here V is 50, so 50 into I value we calculated as 80 by 3. So 50 into 80 by 3 into T. T is 60 into 60. So the value we are getting as 4.8 into 10 raised to 6 joule. Therefore the heat generated is 4.8 into 10 raised to 6 joule. Now we can conclude the video. The rest of the questions we can discuss in the next part. And if you like my videos, please like, share and subscribe. Thanks for watching.